Okay, just let me explain a little bit about this week here before we get going. Part of being in an honors class is sometimes you are taught things that aren't required to be taught. Okay, as far as the Regents exam goes, we're done with this unit. Okay, I've taught you everything you need to know about right triangles. All right, but I want to do something a little bit above where we've been. So that's what we're doing this week. All right, we're kind of taking this whole unit to an honors level. And here's why I'm going to do it. Let's review everything we've done. Hill-Sass, 45, 45, 30, 60, sine, cosine, tangent, elevation, depression angles. But they can only be used in what type of triangle? It's the right triangle. And you probably never really thought about it, but doesn't it seem ridiculous that you have to have a right triangle only to use all these great things? You have to have a right. And what are the odds, really, you're going to get a right triangle? Probably slim. All right, so what happens if I just have any triangle, but I still want to find a side or angle? That's what we're going to do this week. What's out there mathematically that, okay, I don't have a right triangle, but I'm still going to find a side? What's out there other than sine, cosine, and tangent? Okay, so that's our goal this week I'm going to show you two things today and tomorrow that no matter what type of triangle it is, you can always find a side and an angle. Okay? First one I'm going to show you today is called the law of sines. Law of sines. Can you just go to example number 1 down at the bottom? We could read through this, but I want to just get rocking and rolling. All right? So if you take a look at my triangle, is it a right triangle? No! So everything we've learned so far I can't use. But I am asking you to solve triangle ABC. Anybody, let's go back to one of the questions we did last week in notes. When you're asked to solve for a triangle, what am I looking for at the end here? Anything that's missing. Any side that is missing, any angle that is missing. And let's take a look at this triangle here. How many sides are missing? 2, so I got to find those 2 sides, and how many angles? 1. So if one angle's missing, can we start there? I don't need any tricky sine, cosine, tangent business, because all I need to know is how many degrees do all 3 add up to? There you go, 180. So we can find angle C right now. That's an easy starting point. And just so I can hear from some of your lovely voices, angle C, 23, 30 degrees. There it is. All right. Now let's get to the sides. Everyone understand why I can't use anything we've done so far this unit? It's not what type of triangle. It's not a right triangle. All that stuff means nothing right now. All right, so I need something else. So what I'm going to introduce today is what's called the law of sines. Here's what the law of sines says. It's 2 ratios equal to each other. 2 ratios. Here's what the first ratio says. Take any side of the triangle. Take any side of the triangle. And I'll mark this up in a second. Put it over the sine of the angle across from it. All right, so again, this is a side. This is the angle across from the side. Everyone good? That ratio. So 10 over the sine of 50, 6 over the sine of 80, whatever it is. Okay? That ratio, ready, is equal to another side over the sine of the angle across from it. Those 2 ratios always equal. To give me a side, put it over the sine of the angle across, and do the same thing for another pair. They'll always be equal in any type, any type, including a right triangle. This works for anything. Okay? So yeah, you might see, it's okay if you put sine of 90 here sometimes. That's okay. This is for any type of triangle, right or not right. Good? So let's use it on this triangle here to find one of the 2 missing sides I have. I'm going to go slow. One doesn't make it great, so if you're still a little iffy at the end, that's fine. We got 2 more to go afterwards. 12, you ready? Big job. 12 in the house, 12. 12. 12. Hi, Maya. Let's pick a side. What side do you want to find? Okay, let's do it. Let's find side A. Everyone ready? So I'm going to say side A over, here's the first ratio we're going to create. What is the angle across from it? So I'm going to say not 110, not over 110, but sine of 110. That ratio is the same as any other side and the angle across from it in the same triangle. So anybody know what? I don't want to put C here. Everyone clear on that? I don't want to put C there. All right, now we're getting crazy. Nuts. And I don't want to go there. Is there another side and angle combination that is already there? 5, what's another side I know? So 28 over, what's the angle across from it? Sine of 40. There is the law of sines in action. Any triangle, guys. Any triangle, that'll work. How are we going to solve this now? How are you going to solve for A? It's a proportion. Cross multiply. Here you go. 28 times the sine of 110 equals A times the sine of 40. We've had practice in this last week. How are you going to get A by itself now? How do we get A by itself? Here you go. 15. What do you want me to do here on this right side to get A by itself? There you go. Divide by sine 40. And I believe you guys have fraction templates where you can just plug this entire left side in. Or you can do it piece by piece. I prefer all at once, but so you don't make a mistake. And then I'm looking for round your final answers to the nearest tenth. What do you got? 5 nearest tenth on fire today? Point 0.9? 0.9? Okay, still got to solve for C now. Can I do Pythag? Hey, Pythag? Pythag, why not? Why is that embarrassing? It's not a right triangle. Get out of there. But I can still do law of sines. Okay, so let's find C now. So I can say one ratio, C over 9. What's the angle across from C now? 30, sine 30. And now for the other ratio, this is just a preference for me because now you guys know 2 side angle relationships. I always like the given one. All right, why do I like the given one? What happens if you made a mistake here? You're probably going to be wrong here. All right, so I always like to use whatever was given, which was to us 28 and 40. 28 over sine 40. All right, cross them up. Any triangle this can be used. The problem tomorrow we'll have is what happens if I don't have enough information to use it? Is there something else out there? Oh, 16. What do you want to do on both sides? Thanks, champ. Everyone have a good weekend. Good to hear. Do anything great? Oh, really? That sounds good. All right, let's move on. C. 13, what do you got for me? C? Yeah. Don't go on to the next one yet. Okay. I always get asked, is there any way we can check to see maybe if we did it right or not? The answer is no, but you can tell probably that you're going in the right direction. I put the side lengths already up there. Anybody remember a theorem from earlier in the year? That kind of matches what I have up here already. That kind of tells me those side lengths are probably going to be right. Anybody remember? And it fits into the theorem, Michael? Okay, one thing is two smaller sides have to add up greater than no hypotenuse here, right triangles only. The sum of two sides has to be bigger than the third. And Kevin, the placement of these, when you go back, the largest side better be across from the largest angle, smallest side across from the smallest angle. All right, which it is here for us. All good? All right, one does not make you great. All right, I'll let you guys set that up. We got a little something new here when you do the directions. Something we haven't seen in the directions late at all, actually. T equal to 21. What do you think that's referencing? Lowercase t equal to 21. If you had to guess, you're probably right. Lowercase t is referring to the side across from angle t. Yep, so the side across from angle t is 21. Find lowercase d, which would be side across from angle d. So just get used to that notation now. Lowercase letters are the sides across from the angles. All right, everyone ready to help me with that triangle? You get it, Izzy? All right, just one person, that's fine. Everyone ready for that triangle? DAT, yeah, yep, that triangle, yep, little slang there. Nobody had any, the bear, huge paws, had them all my life? Nothing? Come on, that's a classic one in honors geometry. Classic. Why the long pause? I've had them all my life. Why the huge pause? I've had them all my life. Classic. Come on, kids. All right, never mind. Here we go. Give me a side angle relationship that you know. So I can start a ratio off. Give me a side angle relationship that you know here. 3, start us off right. $48, where do we get that from, Charlotte? Because I don't see a 48 on here. Angle T, yep, 108, 180 minus 27 minus 105. All right, everyone, all right? Can't freak out. It's not going to be, everything's just not going to be spoon-fed to you. All right, can't serve it for you. Got to find it on your own sometimes. And then what about my other side relationship for the other ratio? Here you go, 9. There we go. So D times the sine of 48. Yeah, cross multiply. 21 times the sine of 27. Okay, what are you dividing both sides by to get D by itself? Just want to hear it. 16, what are you dividing both sides by? Thank you. What am I asking for? Nearest integer? Whew. 12. What do we have?
Oh, no, 11. No, 13.
Which one are we going with there?
13.
All right, got it. Yeah, it should have been small, at least smaller than 21, right? Because 20, the bigger angle is across from 21, not across from D. Anybody have any issues here? We got to do one more thing with it, and that is how do I use law of sines to find an angle now instead of a side? All right, here we go. Everyone good with that triangle? I had to do it one more time. Anybody? Okay, forget you. Hopefully period 6 has got better for me. Again, see the new notation, lowercase c, lowercase b. Those are the sides across from the angles. C10, B7, find angle B nearest degree. All right, we could still do law of sines. Here we go. We can still use it. Give me a side angle relationship, you know. 2.
10 over sine of 112.
Okay, you can stop there. Everybody good? Okay, I'm interested to see what you're going to say next. What's the other side relationship I need to put in for the second ratio? Let's see if we got this. 21. Oh boy. There goes my confidence level. What's the other side I know, Dylan? 7. All right. Come on now. Act like you belong here. What do you think I'm going to put over this? Thank you. Not just x. I can't just leave it x. It's got to be sine of the variable. I'm going to put a b in because I'm looking for angle b, but you can put x in too. But just it's got to be attached with the sine. All right, ready? Let's see if we remember anything from last week. I'm still cross multiplying. 7 times the sine of 112 equals 10 times sine of b. Not solving for b, get sine b all by itself. So what am I going to do here to the right side of my equation to get sine b by itself? Here you go, 1. Okay, everyone, go ahead, divide by 10. And then everyone goes to their calculator. I'll do the same with you. I'm getting 0.6490, just like you guys. Is that my angle measure, though? No, that's what sine b equals. It's not what b equals. It's what sine b equals. So I need your help now. If I know sine of b is equal to that, how do I make it into angle b from last week? And some of you guys may be confused or don't remember because most of the time last week we had this equal to a fraction instead of a long decimal, but who's going to dig deep here? How do I get angle b if I know the sine of b is equal to that decimal? How do I get angle b now from last week? Angle b. Oh, here we go. What do you got, Thug Life? Yeah, that hood that makes you hardcore. We're all scared. Inverse, thank you. Inverse of sine. Yep. Hard hitting Delmar. Yep. B is equal to east side or west side, Delmar. I know, it really depends. Yep. I'm going to do the inverse of sine. Everyone remember that? You need to find an angle, got to use the inverse. So I just go back to my calculator, inverse sine. You guys can copy paste it, or again, I think I've shown you this before. You can also do second negative, which just brings up the previous answer. Or some of you guys can copy paste too. If you can't copy paste, there's the way around it. All right, second negative. We'll put that answer right in there. And then that angle B to the nearest degree. $40 degrees. All right. All good? That's all I got for you. Tomorrow is what happens when law of sines isn't good enough. We need something else now. You have 7 problems from the book. Get going. You can easily finish them. We got to take care of some survivor business from test 1 for quiz 1 from the Hills and Sass stuff. So we're not going to shoot darts on this one. Sorry. So Izzy, Maya, Natalie, Jacob, and Dylan, come on up. Random generator time. This is from quiz 1, remember.